Hello everyone, welcome back. I hope you are as excited as I am to get started with Insertion Sort. So let's get right to it. Again, we're just going to take it step by step and examine our needs and go from there. So what's the first thing we need? We need an array to sort. Let's get on that. We're going to make an array. I'll name it array again, of course, because what else would I name it? And we're just going to make a very simple array of numbers. For whatever reason, I like to start with 6, 3, 7, 1, 9, 4. Yep, that sounds good. Okay, just a very simple, small array. Oopsies, we need a new int. Excuse that. Okay, so now we have our array. So now let's keep going. So again, we need a basic for loop to at least, in some sort of way, navigate through our array in one way or the other. So we're going to create an int. I'll just name it I this time. Okay, and remember that the thing that's unique about Insertion Sort is that we start with the second element, because we always start comparing it to the elements lower than the current element. So if we were to start with like the 0th element, then there's nothing to compare it to below. So we're going to start with the second element, which has an index of 1. Okay, that's good. And then what we're going to do is we're going to keep it I less than array.length. So what this will do is this has the length of the array, but keeps it less than that because, of course, arrays start at 0, so we don't need it to actually go all the way to the full length, which is why we have the less than. And we're going to increment I by 1 each time. Okay, so we have that kind of basic down. So what that means is when we first start this, we are going to begin with array 1, which is this element right here. And so then just kind of to get a better understanding of what we need to do with this algorithm, let's start with, let's just say this first iteration passed and we're on the second one. So we're on array of element 2, which is this 7 right here. So what do we need to do? We need to compare it to the 3, and what would end up happening is these get switched. So we need to compare it to the 6 and the 3. So let's kind of handle that. Let's see. So what we're going to do is we are going to start for j is equal to, and then we're going to always start with the current element we're on. So let's say we're on this element right here. We're going to start with that same index. So we're going to set j equal to I. Okay, so we have that. And now, as a precaution, we always want to make sure j is greater than 0, because what we're actually going to be doing is, remember, we go backwards when we're comparing the elements. So we're going to go to here. So we're actually, I guess you could call it like decrementing j. We're decreasing it is probably a better way to phrase it. So we actually are using the minus, which is fairly rare, but in algorithms it's more common, especially with Insertion Sort. It's in my opinion the best way to go about it. Okay, so we're going to compare this element, I guess we could say, with the one below it. So we could do it in an if statement if we really wanted to, but what I think the more efficient way to code is if we go, in addition, at the end within a for loop. I don't know if you've ever seen that before. It's totally acceptable, just not, again, very common. We're going to do our comparison here. So we want to make sure that array j is going to be greater than, array j is going to be less than the one below it, array j minus 1. So again, we want to make sure that, we don't need to make sure, but we want to test to see if this is less than this one, we need to insert it and keep continuing with the array. But if it's not less than this one, then we can actually cut out the array. Or I guess we can break out of the array is the phrasing I should use. Because remember that this portion will already be sorted. It says if it's 3, 6. And so since in this case 7 is not less than 6, 7 is greater than 6, this condition will fail and the loop will break. Because of course this is already in its correct spot. However, if this were to say be 5, this would hold true, and we need to continue with this this for loop, and then we would be testing it with 3, and then of course 5 is greater than 3, so we'd stop there. So we know that the element would have to go here. Let's just kind of change things back just so we have a better test here. 6, 3, and 7. Okay, so we have that. So if this test succeeds, if this number is less than this one, what do we have to do? Well, we have to set array j, which is going to be this. We're going to want to shift the element below it up. So we're going to set array j equal to array j minus 1. So what this effectively is going to do is, if say this were again, I'll change it back just for the sake. All right, I'll go 4. Why don't I just keep it like this for a while? What this will do is it's going to shift this element up. So this will become a 6 as well. So we're going to copy this one over. That's how we're going to accomplish that. Okay. I'm getting some errors here. Sorry about that. We need to actually initialize that. Int j there. Okay. And so now that looks good. Okay. So let's kind of sort through here. We're going to see that it's going to kind of loop through, compare. It would go here, it would stay here. So it looks like we're doing pretty good, but we need to complete this kind of process, because remember, let's say that like this 7 slides up here with this 1, and then what would happen is this 6 slides up, and then this 3 slides up, and then wait, well, what happened to the 1? We're at the last element now. We're at the point where we need to break. Well, that's a great point, and that is the last line we need to put in here. So what we're going to want to end up doing is we're going to put array j, and we are going to need to set it equal to the element that we originally started with. So this raises a problem because we've been overwriting j. So what we're going to need to do is we're just going to need to create, again, like a temporary variable here. So I'll create a key. I'll call it, or you could call it, I guess I'll call it temp to stay consistent with myself. And so what I need to do is each time we loop through, when we pick an element that we are going to insert, we need to set our temporary variable equal to that. So remember, that's going to be this one right here. We're going to start with 3, and then it's going to go to 6, 7, 9, 4. So that's going to kind of how it works. So we're going to set temp equal to array I is how we're going to do that. And then, so we're going to set array j equal to temporary, because now we'll have that variable stored, so it's not going to pose a problem for us. And actually, sorry again, I have this misdeclared because it needs to be out here because of the issue of the hierarchy. It doesn't know that j exists out there. So now we are good to go. Okay, and so now let's just create a little test again. System.out.println arrays dot toString array. All right, there we go. Okay, and let me mix this up again. 6. I'll go 1. Might as well. Okay, and let's try it out. And actually, before we try it out, just caught something real quick. Since we created this, we're altering this array j variable. So this actually needs to be our temporary variable as well, because we don't want it to be the version that is getting altered. So let's change that to temporary as well. Now we're good to go. And we'll see that we get our sorted array over here. So this one works great as well. Pretty short is actually really short too. You could probably condense this to about 10 lines if you really tried. So just a 10-line sorting algorithm, quite simple, a really good start. And now next tutorial, we're going to jump into the big daddy merge sort. I hope you're ready. I'll see you there.